You can see the 4 boosters.
50 seconds countdown. Well, certainly this mission will help us understand the Earth's formation, its evolution over billions of years. 30 seconds countdown.
The onboard computer is now in charge of everything.
All right. And certainly we'll bring you every detail from the launch as the rocket blasts off. Final 10 seconds countdown.
3, 2, 1. Ignition.
You're now watching live feed from Wenchang Satellite Launch Center. China's Chang'e 6 mission blasts off into the sky. It's all systems go, Professor Yang.
So magnificent. And now the tower is clear.
It's now starting its epic journey to the moon.
So at the moment, 17 seconds after liftoff will be the pitch over, change the direction.
Right.
And now you can see this is a video captured by the camera mounted on the launch vehicle. Actually speaking, on the core stage, you can see 2 of the rocket boosters.
Right. Are the cameras infrared?
This is a visible light camera.
Visible light camera.
Yep. And you can see the flames of the boosters.
Yeah.
Each have 2 rocket engines, YF-100 rocket engines with a thrust more than 120 tons.
Sure.
And the booster will work for nearly 3 minutes.
3 minutes.
Yes.
And then it will detach from
We
the
can
rocket.
hear from the ground stations. The voice comes from the reporters of the ground stations. They mentioned that the telemetry received normally and the spacecraft fly normally.
Now, as we mentioned, this mission will last for 53 days, much longer than the previous mission,
Exactly.
the Chang'e 5. It's going to make a soft landing on the far side of the moon, somewhere around the Aitken Basin. And then it's going to bring back lunar samples from the moon.
Next step will be the separation of the side boosters.
Yeah.
We have 4 boosters within several seconds.
As we were discussing, Professor Yang, how long would it take for the probe to actually land on the moon?
Well, the powered descent only lasts for several minutes, less than 10 minutes. But they will wait for this moment on the circumlunar orbit for several days.
Yeah.
So that depends on the design of the whole mission profile. Next, we will be seeing the separation of the booster soon.
Now, even the launch moment was successful. We couldn't say that this entire mission is a success because every step of the way will be pivotal for the entire mission. There's complicated procedures involved, and we're going to bring you all the details in our live coverage. What will be the moment that marks the success of the launch phase of this mission?
Yes.
Which part?
The separation of the probe with the end stage of the launch vehicle, and also that's the unfolding of the solar panels.
Solar panels.
Okay, great, beautiful.
Boosters.
Yes, all the 4 side boosters separated normally.
Applause from the control center. And that's certainly another step forward.
Yes. So the rocket will continue to work several minutes. So and the next critical step will be the separation of the payload fairing.
Right.
Because that it's in the ascending phase and its altitude is go higher and higher. So at a certain moment, we do not need the payload fairing to protect the probe.
Right. We are now a little over 4 minutes into this mission, and it looks like so far so good.
So now it's a flying of the first stage. So as I mentioned, the first stage have 2 rocket engines with liquid hydrogen and liquid oxygen as a propellant.
Sure.
And each of the... Okay, this is a 3D animation.
3D animation,
Yeah.
and back
this
to
is a
the
video
cameras
from the camera.
installed.
Yeah.
Right.
And you can see this is now today, at this moment, we can see the fuselage of the first stage. And as I mentioned, we have 2 rocket engines on the first stage of the YF-77 rocket engine. Each have a thrust more than 50 tons. And we just heard a voice. That's the ground station, the radar tracking the spacecraft very normally.
And approximately how high is it? How far away is it now from Earth? Because we can now see that beautiful view of the Earth.
Yes, actually speaking, it's already, I believe, it's already more than 50 kilometers high. And when it is high enough, as I mentioned, we will conduct the separation of the payload fairing. Oh, you can already see on the left our screen, we can see the camera inside the payload fairing. We've already seen the scene inside the payload fairing.
Right. That's, of course, giving us a very clear look, a very clear vision of the payload from inside the probe.
Yeah, inside the payload fairing. So we can see that the Chang'e 6 probe is stored in this payload fairing.
Right.
And next, okay, great,
It's
beautiful.
Opening up.
Separated. So we don't need as I mentioned, because it's already high enough, we don't need the protection of the 2 pairs of payload fairing. So it's already in outer space.
So next phase will be the second stage ignition.
First, we should separate the first stage.
First stage, right.
Yeah. Just about 8 minutes after the liftoff will be the first shutdown of the first stage. Sorry, the separation of the first stage.
Separation of the first stage followed by the second stage ignition. Right.
Yeah.
Wow.
So this is the 3D animation, and this is a video from the board on the rocket. Now you can see the beautiful Earth and the curve of the horizon of the Earth.
It really looks like, I know it is a technically demanding and challenging mission, but it's also a very romantic and beautiful journey.
Yeah, what you see now is just above the Pacific Ocean.
Right. This mission is going to last for 53 days, and it consists of 11 phases. Every detail, every single action could have an effect on the entire mission.
Every step, as you mentioned, every step is important. Every step is critical. So although the thrust of the core stage, as I mentioned, of the first stage is much smaller than its 4 boosters, but it will work longer because the liquid hydrogen has higher energy. Great, the flight is normal according to the voice reported by the ground stations.
Right. So correct me if I'm wrong, Professor. The spacecraft consists of 4 separate components.
Exactly.
There's an orbiter, lander, ascender, and the re-entry module. And
exactly.
After launch, the Chang'e 6 will travel to the moon and enter lunar orbit, and the lander and the ascender will travel to the surface.
Yes.
While the orbiter and re-entry module stay in orbit.
Yeah. The combination of the orbiter and the returner will stay in the lunar orbit to wait for the ascender.
And the ascender and the lander will touch down at the far side of the moon and collect samples to the re-entry module.
No, to the ascender. So they get the samples in the container. Okay. Great. The first stage has separated.
First stage separation.
And now will be the ignition of the second stage.
So my understanding is that the ascender will blast back into lunar orbit and transfer the sample to the re-entry module.
Look, you can see that we can see this is a camera mounted on the second stage. We can see the first stage separate and going far behind the second stage.
Another view from the
This
I
is
think
a
that's
view
the
of
payload.
we can see that there is also a camera mounted near the rocket engines, so we can see the working of the rocket engines. So on the right of the screen, we can see the video camera mounted on the rear part of our second stage. So we can monitor the working of the rocket engines. This rocket engine is called YF-75D. So it is also use liquid hydrogen and liquid oxygen as the propellant. It will work much longer, although the thrust is much smaller than the first stage. But it is very unique because it will ignite twice. So with the first ignition, it will burn several minutes. So at the moment, about more than 10 minutes after launch, it will shut down first.
Yeah.
So at this moment, it will enter what we call the parking orbit. And it will float in this parking orbit for about 10 minutes, which calls this coast phase.
And once it enters orbit, well, before it touches down on the moon and after it goes into orbit, one very important step is to slow down the probe. Just to make sure it makes a soft landing on the moon.
So you know that there are two steps. The first is what we call the lunar orbit insertion, which means that we slow down the vehicle from the translunar orbit to the circumlunar orbit. And then we, with what I mentioned, as you mentioned, the combination of the lander and ascender, with the combination of these two spacecraft, we use the propulsion system to slow down the vehicle from about 1700 meters per second to zero. Also, the altitude from about 100 kilometers to zero within only 10 minutes. So this is also another critical step.
Fascinating. And another highlight of the mission is that there's this relay satellite.
Yes, the Magpie Bridge 2.
鹊桥 2 in Mandarin and Magpie Bridge 2 in English. So simply put, there is no direct line of sight from the Earth to the far side of the moon.
Absolutely.
And that's why we need that relay satellite to learn more about what's going on there and also receive data.
Well, you know, as you mentioned, the Magpie Bridge 2 or the 鹊桥 2 data relay satellite. But I should emphasize that 鹊桥 2 is an extremely important part for our sample return mission from the far side of the moon. We cannot see the our probe, the lander on the lunar surface with our ground stations.
Sure.
And not only, you know, that this time the 鹊桥 2 or the Magpie Bridge 2 not only acts as a bridge to conduct the communication, but also it is very important for us to measure the precise position and velocity of the lander, the coordinate of the landing point, and also during the ascending phase of the ascender. You know that the basic requirement for rendezvous and docking is that we must ensure the ascender entered an orbit with the same orbital plane of the orbiter.
Sure.
So that's really important.
So does the Magpie Bridge providing data or visual images from the far side of the moon?
Okay, we can see, we hear the voice of the ground commander that the second stage has already shut down for the first time. Now the whole combination of the rocket and our probe has entered the coast phase. So it will last about 10 more minutes.
10 more minutes.
You know that for any probe to the moon, we must have or conduct the translunar orbit insertion near the equator. But you know, although you know that Hainan province is the most southern province of China, but still it's not located on the equator. So that is reason why we need a coast phase. So when the first shutdown of the second stage completed, we will have a coast phase about 10 more minutes, and then we ignite again near the equator, and then it will be the translunar orbit insertion. We can just wait.
So again, the Magpie Bridge 2, does it provide data or visual images of how the probe is there retrieving samples from the Aitken Basin?
Actually speaking, the camera mounted on the lander will monitor the whole sampling procedure. And then the signals of these videos will transfer first to our Magpie Bridge 2 data relay satellite, and then forward it to the Earth.
Is there a time delay, I would imagine?
The time delay is only 1 more second. You can
a little
neglect
more than a second.
Yeah, because you know that it's too far from the Earth. The distance is more than 380,000 kilometers away.
What if the command center gives some orders to the probe? Does the Magpie Bridge 2 also do the job?
Exactly. So we cannot directly send the command to the probe to the lander directly. We can only to first send the command to the Magpie Bridge 2 and then forward that to the lander. So now we can still, you know, that at this moment we still have the communication with the spacecraft with the help of our Tianlian data relay satellite. So you can see we can still send the video captured by the camera mounted on the second stage.
Yeah.
So this is a 3D animation, but it is based on the real data we get from the parameters measured by the sensors on board our spacecraft. So it's just fly above the Pacific Ocean.
Right.
So when it reaches the equator, it will ignite again.
Yeah. Before we get to the technical details of this mission, Professor Yang, let's talk about the different types of landing or different types of lunar exploration.
Yep.
Because there are the flybys, there's the hard landings, and then there's the soft landing. I remember there's one more type. Which part is the most technically challenging?
Absolutely, the sample return will be the most challenging one, like this one. You know that, as we discussed before, China has already conducted 3 phases of the lunar exploration program in 3 very simple Chinese words. 绕, 落, 回.
Right.
绕 means orbiting in English. And you know that we conducted it by the Chang'e 1 probe and the Chang'e 2. And 落 means landing. Landing conducted by the Chang'e 3 and the Chang'e 4. And 回 means sample return. So we conducted with Chang'e 5. So you see, for each one step, we also need to do the things on the previous step. For instance, if you want to conduct a landing, you must have the orbiting. And for the sample return, you must first have the orbiting and then the landing.
Yeah, it's always a follow-up mission of the previous one.
So we master the key technologies one by one.
So China's lunar exploration mission, what is the final aim of this entire mission?
Well, you know that today we are already in the 4th phase of our lunar exploration program. So for this program, we will set up or build a permanent base on the lunar surface called the International Lunar Station. So it is an international cooperation with other countries. So today already have many countries involved in this program. And you know that in the 4th phase of our lunar exploration, we only have the Chang'e 7 and the Chang'e 8 probes landed in the South Pole regions of the Moon. So they will form the most essential or the basic configuration of our research station. So we can see that in the commanding or flight control hall of the Wenchang Space Launch Site, we can see the time of the total flight duration. Exactly. So this time, we also can see from this 3D animation, which is driven by the real data, we can see the real attitude and also the position of our combination of the Chang'e 6 probe and the second stage of the Long March 5.
Yeah, and of course these scientific data are crucial for ground control command to monitor the status of this spacecraft.
So as I mentioned, the spacecraft need to fly from Wenchang Space Launch Center, spacecraft launch site to the equator. So it do need several minutes.
Sure. So again, our plan to build a lunar research base.
Exactly.
Would it be on the far side of the moon?
It still depends on which is the final chosen position. But absolutely, it will near the South Pole, whether it will on the near side or on the far side of the moon. But still, you know that we've already talked about the Qiuqiao 2 data relay satellite. It is very interesting that the Qiuqiao 2 chose a quite different orbit comparing with its successor, the Qiuqiao 1. So you know that the Qiuqiao 1 located in what we call the halo orbit, very close